Hi guys, welcome back. Today we are breaking down the technical requirements of Nordic Fast Frequency Reserve (FFR). Quick overview of today's video, 6 parts. FFR concept, pre-qualification process, technical requirements, testing and verification, real-time telemetry and data logging. Finally, summary. Let's begin with the basis. What is FFR? FFR stands for Fast Frequency Reserve, which is intended to be a fast, active power support, responding to a frequency deviation within milliseconds to seconds, served as the initial defense mechanism. First step is pre-qualification. To join the FFR markets, you must pass TSO pre-qualification process. TSO means Transmission System Operator. For pre-qualification for first time, first, provider submit the application package to the TSO and finish the testing. Then within 8 weeks, for documentation checking from TSO, if additional documentation is required, provider should provide it within 4 weeks, otherwise the application is deemed withdrawn. When the application is finished, TSO should within 3 months either pre-qualify or deny the applications. Finally, approval notification from TSO, including the specific time for reassessment. A reminder, the test results included in an application must not be older than 1 year. To apply it, you will need a comprehensive set of documents. Application letter, provider information, capacity, maximum activation time, corresponding frequency, activation level, support duration, test report, documentation of telemetry data, and data logging. The energy storage system also needs to provide rated power megawatt and energy megawatt hour, as well as the controller related information. And it is very important to comply with TSO cybersecurity provision. FFR qualification is not permanent. It needs to be reassessed every 5 years. Additionally, if you make any significant changes to your system, like adjust the controller or upgrading the equipment, that could affect how the FFR service performs. You will need to go through the full pre-qualification process again. Next point, technical requirements. There are 3 activation types to choose, each with a different frequency threshold and a maximum activation time. Choose one in advance and no power drop during activation process. For example, the activation level is 49.5 Hz here. So the corresponding maximum full activation time is 0.7 seconds within the pre-qualified active power. You also need to choose a support duration. There are 2 options, long duration FFR and short duration FFR. For long duration FFR, support at least 30 seconds, and there is no limitation on the rate of deactivation. and can recharge immediately after the event. While short-duration FFR support at least 5 seconds, the rate of deactivation is limited to the maximum 20% of the pre-qualified FFR capacity per second. No recharge within 15 seconds after support duration. There are also rules for over-delivery, recovery, and repeatability. You are allowed to provide up to 20% more power than the pre-qualified capacity, which can go up to 35% with special permission from TSO. For example, the pre-qualified capacity is 10 MW. If the over-delivery power is 20%, then the maximum capacity will be 12 MW. When recovering, the charging power is up to 25% of pre-qualified capacity. Last but not least, after activation, the FFR provider must be ready for a new activation cycle within 15 minutes. To prove your system meets these requirements, rigorous testing and verification are mandatory. This is the critical step for getting approved. First, let's cover the accuracy and sampling requirements. The sampling rate must be at least 10 Hz. That means a data point every 100 milliseconds. The accuracy of the active power depends on the capacity. If the capacity is less than 2 MW, the accuracy must be within plus and minus 5%. If the capacity is from 2 MW to 10 MW, the accuracy will be within plus and minus 1%. If the capacity is exceed 10 MW, the accuracy will be plus and minus 0.5%. And all the parameters is within a resolution of 0.01 megawatt. Sorry for the error. So this here is exceed more than 10 megawatt. And the grid frequency and applied frequency signal are both within a resolution and accuracy of 10 mHz. And remember, all the testing codes are your responsibilities. Now let's talk about the testing method. The first and most recommended test method by the TSO is external synthetic frequency test signal. What does this mean? You can see the figures here. In these diagrams, the system uses a synthetic frequency source here to output target frequency, for example, 49.5 Hz. Signal goes through a frequency transducer, and it will translate the signal to the controller, the on-site controller, and then controller will send the command to the energy storage systems, and the system will respond via the real on-site signal path to output qualified capacity. Just like a real grid event, This is the most accurate way to test the system's response time, so it is the preferred method. While method 2 includes two testing methods, method 2A and method 2B. Method 2A is regarding the internal controller synthetic frequency test signal. The signal generated directly within the controller, so faster, but exclude frequency transducer delay. So this method cannot be used alone and must combine with method 2B. Method 2B, system natural frequency variation as test signal, use real grid fluctuations for testing. No artificial signal inside, because it just waits for the variations of grid frequency. But you must set the frequency activation level slightly lower than the normal grid frequency. For example, the threshold is set in 49.9 Hz, so the FFR can be easily activated. But the disadvantage is this method cannot verify the real frequency activation level. So to conclude, the method 1 is considered technically equivalent to using method 2A and method 2B in combination. Okay, let's look at the test signals used. Step testing and ramp testing. Step testing must consist of two steps. The initial frequency is from 49.9 Hz to 50.1 Hz. And step 1, the initial frequency dropped to frequency 1. Here, frequency 1, and also here, frequency 1. Frequency 1 is more than activation threshold, but less than or equal to activation threshold plus 0.05 Hz. In this situation, FFR must not be activated. Step 2, when the frequency drops to frequency Step 2, when the frequency 1 drops to frequency 2, it means frequency 2 will more than or equal to activation threshold minus 0.05 Hz and less than or equal to activation threshold. In this situation, the FFR must be activated. For example, activation threshold is 49.6 Hz here, and frequency 1 is here, 49.65 Hz. There is no activation, while frequency 2 is 49.55 Hz, and there will be an activation. The next method is regarding the ramp testing. The frequency starts at normal range from 49.9 Hz to 50.1 Hz and decrease slowly, but no steeper than 0.2 Hz per second. The system must activate within the threshold minus and plus 0.05 Hz. For example, the threshold is 49.5 Hz. FFR activated between 49.45 Hz and 49.55 Hz. If a full pre-qualification procedure has been performed less than 5 years, a simplified reassessment use the system natural frequency variation as test signal can be performed. See method 2b. But if failed to pass it, a full pre-qualification procedure has to be performed. Next slide is regarding the requirements on real-time telemetry and data logging. For real-time telemetry update available and maintain capacity to TSO at least per second, per minute. Store all relevant data for minimum of 14 days with a sampling rate of at least 10 Hz and submit standard CSV files to TSO within 5 working days. Okay, that's all the technical requirements for Nordic FFR. You can also go through the details in the documentation. Technical requirements for fast frequency reserve provision in the Nordic synchronous area. External documents. Thanks for watching. Next video we will discuss some common questions and answers regarding the Nordic FFR requirements. See you. Bye bye.